Welcome to Lacea class. I am your teacher, John Lacea.
A blessed day to everyone! Today, we are going to learn passive infrared sensor, motion detection. A passive infrared or PIR sensor is a type of electronic sensor that detects infrared radiation emitted by objects within its field of view. It is commonly used in motion detectors such as those found in security systems and automatically triggered lighting. Passive infrared sensors are considered passive because they do not emit their own infrared radiation, but rather detect the infrared energy given off by other objects. The HC-SR501 passive infrared motion sensor can typically detect motion up to 7 meters or equivalent to 23 feet away. This is the default, but this can be adjusted. The sensor has a sensitivity adjustment that allows you to fine-tune the detection range between 3 meters and 7 meters. If we want to detect short distance, like 3 meters, then we turn the sensitivity potentiometer counterclockwise. If we want to detect long distance, like up to maximum of 7 meters, then we turn the sensitivity potentiometer clockwise. However, factors like the size and heat signature of the object being detected, as well as environmental conditions, can also affect the actual detection range or distance. The time or hold time potentiometer determines how long the output of the passive infrared sensor module will remain high after detection motion. The range is from about 3 seconds to 5 minutes. If we want to have a short time delay, then we turn the hold time potentiometer counterclockwise. If we want to have long time delay, such as up to a maximum of 5 minutes, then we turn the hold time potentiometer clockwise. The passive infrared sensor has jumper settings for selecting the trigger mode. There are 2 trigger modes: the triggering repeatable trigger, high mode or H mode, and the non-retriggering, non-repeatable trigger, low mode or L mode. Retriggering or repeatable trigger, high mode or H mode. In this mode, when motion is detected, the sensor's output goes high and stays high as long as motion is detected within its range. If motion continues to be detected after the initial detection, the output remains high. That high is equivalent to 5 volts, which then be the output returned by the passive infrared sensor. And the time delay is reset, extending the high output duration. Essentially, the sensor retriggers its output, keeping it high as long as motion is present. This mode is useful when you need a continuous high output during sustained motion. The jumper, which is this one, is usually placed on the H or high mode position for retriggering mode. and on the L or low mode position for non-triggering mode. The picture here will show us that the jumper is set to a non-triggering mode or the low mode or the L mode. But if you remove this yellow jumper and then place it here, it will now become the retriggering repeatable trigger high mode or H mode. The second triggering mode is the non-triggering, retriggering, non-repeatable trigger or low mode or L mode. In this mode, when motion is detected, the sensor's output goes high but only for a set time delay, regardless of whether motion continues. After the initial detection and the time delay, the output will return low. Low is equivalent to near to 0 volt. Even if motion is still present, the sensor will not re-trigger its output based on continued motion. It will only activate the high output once per detection event and then wait for the time delay before it can be triggered again. This mode is useful when you need a single high output pulse for its detected motion event, even if motion persists. All objects with a temperature above absolute zero emit infrared radiation. Passive infrared sensors detect the changes in this infrared radiation caused by moving objects. Passive infrared sensors use a pyroelectric material like the lithium tantalate or lithium niobate that generates a voltage when exposed to infrared radiation. Many passive infrared sensors are split into two or more sections. When a warm object like a person moves into the sensor's field of view, it will trigger a change in the infrared radiation reaching its section of the sensor. This change is what the sensor detects as motion. By comparing the signals from the different sections, the sensor can determine if there is a change in infrared radiation, indicating motion, rather than just a change in the ambient temperature. Some common applications of the passive infrared sensor. Number 1, security systems. Passive infrared sensors are a core component of many motion-detecting security systems, triggering alarms or activating cameras when movement is detected. Automatic lighting. They are used to automatically turn lights on when someone enters a room or area, conserving energy. Traffic control. In some cases, they are used to detect vehicles at intersections to adjust traffic light timing. Finally, industrial automation. Passive infrared sensors can be used in various industrial automation applications to detect the presence of objects or people which are moving. Advantages of passive infrared sensor. Number 1, low power consumption. It typically consumes very little power, making them suitable for battery-powered devices. It is cost-effective. Passive infrared sensors are generally inexpensive and readily available, easy to install. They are relatively simple to integrate into various systems and devices. Reliable motion detection. Passive infrared sensors are very good at detecting motion, especially in complete darkness. Limitations of passive infrared sensor. Number 1, no imaging. Passive infrared sensors detect movement but it do not provide any information about what it is moving. False alarms can be triggered by other heat sources like pets, moving branches, or rapid temperature changes. It has a limited range. Their detection range or distance is typically limited depending on the specific sensor and environmental conditions. Line of sight. They need a clear line of sight to the moving object and can be affected by obstructions. The materials we need to build a simple project are the following. Number 1, HC-SR501 Passive Infrared or PIR Motion Sensor. You can purchase the materials at the Lacea Circuits Electronics Engineering Supplies and Services, located at room B314 Lopez Building, Session Road, Baguio City, Philippines. Or you can visit their Facebook with this URL address. Next is we need to have a 5-volt relay module. Arduino Uno R3. We need to have a small breadboard. Either you can use this breadboard that has I think it is 80 holes, or this very small red small breadboard. Next is the 5-volt USB LED bulb. Type A female USB port connector. Next, we need to use jumper wires, USB cable for Arduino Uno, smartphone charger. This smartphone charger can convert to 20 AC to 5 volt, either 1 amperes or 2.1 amperes or 2 amperes adapter. Next is the Arduino C++ IDE to write and compile and upload the program codes to the Arduino Uno microcontroller. We need also to have a laptop or a desktop PC with Windows operating system. This is the wiring diagram for the simple project. First, we need a separate 5-volt power supply for the USB LED bulb. Although we can use the 5-volt of the Arduino Uno, but it will stress out when the current is not enough. So it is safe and better to separate the power supply for the 5-volt LED bulb. We connect the ground and 5 volts wire from the separate 5-volt power supply to the negative and positive rails of the small breadboard. We go to the 5-volt relay. The BCC pin of the relay is connected to the 5-volt of the Arduino Uno. The ground pin of the relay is connected to the ground of the Arduino Uno. The signal pin of the relay is connected to the digital pin number 8 of the Arduino Uno. The normally open of the relay is connected to the positive red pin of the type A female USB port connector. The common pin at the center of the relay is connected to the 5 volt rail of the small breadboard to power the USB LED bulb. Next, we go to the passive infrared sensor module. The BCC pin of the passive infrared sensor module is connected to the 5 volt of the Arduino Uno. The ground pin of the passive infrared sensor module is connected to the ground pin of the Arduino Uno. The data pin of the passive infrared sensor is connected to the digital pin number 5 of the Arduino Uno. The ground pin of the female USB port is connected to the negative rail of the small breadboard. Note that there is no common ground. Let us learn the program codes to be uploaded to the Arduino Uno microcontroller. I have chosen the non-triggering or non-repeatable mode by setting the jumper to low or L mode of the passive infrared sensor. I declared global variables such as the calibration time. We need to calibrate with a minimum or with a 30 seconds calibration time for our passive infrared sensor module to warm up, to be able to have that accuracy of detecting the motion. Next, there is a global variable named low in, that the purpose of this variable low in, long unsigned integer, is to hold the starting time measured in milliseconds after when the passive infrared sensor detected a motion. Why? Because once that the passive infrared sensor detected a motion, we turn on the light bulb, and then we turn the light bulb with a minimum duration time of 60 seconds. I declared a long unsigned integer named pause with a amount of 60,000 milliseconds, or equivalent of 60 seconds, and that is the duration that the light bulb will stay on. I declared some Boolean memory variables such as lock low, initialized to true, take low time, initialized to false. I declared a constant integer named PIR pin, and then assign a permanent value of 5, and that is the digital pin of the PIR sensor's output pin, or the data pin. Whereas the constant integer relay pin with a permanent amount of 8 is the digital pin of the relay input signal. The function setup is automatically invoked and run once at the start of the program execution. First, we need to initialize the baud rate of our serial monitor, because I programmed to display some information for debugging purposes of our simple project to the serial monitor. And then next, we need to assign the relay pin number 8 to an output pin. Whereas the PIR pin, which is digital pin number 5, will be assigned as the input pin. And then after that, we call the digital write that we are going to initialize our passive infrared sensor, the PIR input pin, to a low. Low means there is no motion detected yet. And then we call again the digital write that we assign a high value to the output pin of the relay pin number 8 so that it will switch off the relay to turn off the LED bulb. Next to that, we set up the for loop statement to repeat 30 seconds so that it will give time for the passive infrared sensor to calibrate. And when that 30 seconds of calibration is done, our passive infrared sensor is now active to detect any moving object. When the function setup is finished, executed by the microcontroller, next the function loop is repeatedly invoked and run repeatedly by the microcontroller. The if statement will detect a motion. When the condition digital read PIR pin equals to high, then it means that the PIR or passive infrared sensor detected a motion. The microcontroller runs the body of the if statement. If lock low is true, then it switches the relay to closed circuit, which turn on the light bulb. And then it will display messages onto the serial monitor. We can see some messages displayed here. And then we assign the variable take low time to true. That means that the passive infrared sensor detected motion just a while ago or now. This is the continuation codes of the body of the function loop. If the if statement is for the no motion detected. When the condition digital read PIR pin equals to low, then it means that the passive infrared sensor detected no motion. The microcontroller runs the body of the if statement. If the condition take low time is true, then it means that the passive infrared sensor detected a motion a moment ago. The body of this sub-if statement will get the current time measured in milliseconds to start the transition from low to high with a minimum of 60 seconds. The second sub-if statement will compute the time elapsed and compare if greater than 60 seconds. If the time elapsed is greater than 60 seconds, then it will switch the relay to open circuit, which turn off the light bulb. A minimum of 60 seconds duration of light that it will turn on, and it will take longer when the object is moving. That means that when the passive infrared sensor detected an object, movement or motion, then it will turn on the light bulb for a minimum duration of 60 seconds. When that object is still moving continuously, that 60 seconds can be more than, or it can be greater than 60 seconds. This codes for the non-triggering low or L mode is good for automatic lighting along corridors inside the building. When we look at the sample output printed in the serial monitor, so when we read the first output message, it will calibrate the passive infrared sensors for about 30 seconds. And then after the calibration, it will now start detecting any motion. When there is a motion detected, it will print the motion detected at 36 seconds. At time, 36 seconds. The light will turn off after 60 seconds. And when that object is still moving within that 60 seconds, and then when that object is already away or it is no longer moving, when there is no more motion detected, it will display motion ended at 109 seconds. And then it will again start the passive infrared sensor to be now active and then detect now any motion caused by any objects.
Ladies and gentlemen, let us run and test.
Master, come here and play with me.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.